I have a 1,000-pound rated trailer wheel. Well, actually almost a wheel. It has a solid rubber wheel that I'm not real thrilled with. And the goal here is to replace this wheel with a better setup. In this case, pneumatic tire, easy to roll wheel. This is for our motorcycle trailer, for the XR350 and XR500 that we use for the magazine. And this is a good opportunity to demonstrate cutting. The plan is to remove this tire so I don't set it on fire and cut off the bracket, then go about welding the new piece on. And I'll introduce the use of oxyacetylene cutting. And one thing I'd mention is oxyacetylene cutting is very rapidly being replaced by plasma cutters. Quality plasma cutters available from HTP America, and I'd look at their catalog if you're interested in doing a lot of cutting. Plasma cutting seems to make the best sense. Oxyacetylene works well, there's nothing wrong with that. The only issue there is cost, and you have to perfect the technique of cutting so that you get straight lines. To begin with, let's set up our torch. We've removed our welding tip and now put the cutting head on. Make sure your valve alignment is correct. Valves off. And I like to have the gas adjusting valves facing upward. Position that so it's in between those 2 points. It's a good setup. Now for gas welding, we're going to raise our pressures. We're going to increase the pressures to 20 and 7 pounds per square inch. That's 20 psi of oxygen, 7 psi, 7 psi of acetylene. And one of the issues with cutting is to keep a straight line. So I made a very simple clamp-on guide, if you will, to enable me to follow this cutting line accurately here. As I move the cutting head, I'll maintain a relatively straight line. In the process of doing that, there'll be less cleanup when I'm done, and I'll be able to get on to the welding process of welding the other bracket on that much quicker. And the fundamentals of gas cutting we'll get into in just a moment, but the idea is to create enough heat to melt the metal. We want to apply the oxygen. We're going to blow the oxygen with the handle and create the cut. Keep the cut moving on an angle that's just ahead of us until we've removed the piece. Okay, we'll go through the process of lighting the torch. I want to emphasize that this piece that I'm cutting is galvanized or zinc plated. That's a toxic agent. And when we introduce this much heat, we're going to melt off that toxic agent, if you will, and we want to make sure we don't breathe those fumes, so you want to use adequate ventilation, if necessary a fan. Again, don't breathe harmful fumes, either from the welding materials themselves or when cutting from the materials that you're burning away. Okay, let's begin by lighting the torch. And with oxyacetylene process, we'll start with all the valves closed, as I said earlier. Let's open the oxygen. Base of the handle, this is our green hose. Open that valve several turns. And this is our acetylene line. We'll crack the valve open. Strike a flame. And this is very easy to watch. I take the flame out. I bring the flame right back to the tip. And then I introduce the oxygen. You can see the cone forming. And I bring it right up to the point that we have a nice sharp cutting edge there. This is actually ready to cut now. I've got a heat blanket underneath this to catch the slag. And make sure we don't set the shop on fire. Not to set the shop on fire is always a goal. And the objective here, again, I'm protecting myself from the fumes, is to heat the metal to a molten point and then introduce the oxygen with the handle. Starting to glow red. And press that handle lightly. Maintain an angle with the cutting head. And that should do it. I'll turn off the acetylene first, then the oxygen. And this piece is ready to go. You can see the formation of zinc. That's the zinc chromate, or zinc coming off of the piece. Notice that we have a nice straight line there. We can thank this guide plate for giving us a straight line. That's how quickly we cut this piece off. We'll turn this around and do the other side now. We put our guide plate in place, and the guide plate idea is to give us a straight line and get a nice straight line on that. We'll light the torch, start by cracking the acetylene slightly, take the flame out, bring it right back to the tip, open the oxygen, bring the cone in. We have nice, sharp, pointed, tiny cones there, and we're ready to cut. Again, we bring it up to the piece, we heat it to a liquid point, and then lightly press the oxygen. Increase the oxygen slightly. Move the torch along the guide plate. Notice the angle of the torch. Keeping it steady, angled forward. Bring it right down to the bottom there. Turn the acetylene off first, then the oxygen. And there's our piece. Nice straight cut. A lot less cleanup that way. Reduced amount of slag on the back side. That's optimal. Let's go ahead and take our guide plate off. Here's our piece. Nice straight edge. Very little cleanup here. I'm real pleased with this. I literally could almost weld it as is. I'll probably hit it lightly with a disc grinder just to get this minor amount of slag off of here. Do the same on the opposite side, and then we'll go ahead and weld the other wheel bracket on. Okay, I'm really pleased with the way this turned out. Nice clean cut. 2 seconds worth of cleanup grinding on it. And this is now ready to be fitted. I'm going to go ahead and use the wire feed MIG to weld this because I don't want to pour a lot of heat into this plate. There's a ball bearing underneath it. And so as a result of that, I want to minimize the heat. And using gas welding process causes too much diffusion of heat and would pour heat into that plate. So we're going to stop right here with our oxyacetylene and just use it for cutting in this case. 5 minutes of MIG welding and we have this in place. It's all 4 sides welded. The idea here is that we have a ball bearing on the back side, so I wanted to pour less heat into this piece. You can see that it's barely disturbed the zinc, and so using a confined, more penetrating heat quickly got the job done. We're actually better off doing MIG welding process on this than horsing around with gas welding, although this could have been done with gas. Made a point of using MIG. Got it over with quickly, and we're ready to go. Again, didn't toast the bearings, didn't take the hardness out of the bearings on the back side. We'll put new grease in there and put the wheel on, and we're ready to go.